Okay, here we go. So this is the setup. We're going to test the two multimeters in here. One of them, the black one, that's the KWS-MX18, and the transparent one is a KWS-V20. And we're going to compare them, how they are. The brand name here, that's Keweisi, I suppose. That's the name of it. I suppose we can make it a little bit bigger. Um, yeah, these are the two multimeters, and we're going to test them versus the two Arduinos here. Both of them are identical. They're from Robotdin, a really good company. I find them they are usually better ones from this company. They have pretty good components. They don't die as often, even if they're overvolted or undervolted. So we're going to test these two, the power consumptions on both of them. And here's the power bank and the two USB cables and the two USB multimeters. So let's have a look. There's the power bank, 100%, and unfortunately I have to flip it upside down because the ways that these go in are upside down. So we're gonna have to put one in here and the other one in here. And actually, before starting to do this, we're gonna have to reset them. So to do that, there's a black button up here. If you hold this, you can even hold it while it's inside. Actually, in fact, it needs to, okay, the power bank went off. So it needs to be on, and then you hold it, and then you reset the milliamps and the watt hours, the consumption that's up here, and the time as well, and the watts. Well, not the watts. Okay, so yeah, you can reset it, and the same thing goes for this one. There's a reset button here on the side. This is just straight through USB in. Plug it in, and then USB cable out. Okay, I'll show you how to do that in a moment. So you plug this in. Let's unplug this one. Hold reset, and then I reset it. Yeah. So now it's at 0. The time is at 0, and the milliamps consumed is at 0 as well. Okay. Okay. So let's have a look at these Arduinos. I think actually, in fact, I have to remove the code from one of them. I can't remember which one. Just make sure both of them have the blink sketch on them. So let's check this out. Let's check if it's this one. Okay, that's flashing really fast. It I think this is the one that has something different than just a blink sketch. Okay, so let's have a look up here. Arduino. Let's load this up. Okay, and in here we are going to okay, one moment. I'm going to play around with the sketch. Okay, so in the sketch, oops, this usually happens. Okay, here we go. So this is the blank sketch loop. In fact, actually, no, let's pull up examples, basics. You can't really see that. Blink. Okay. So actually, well, I will just copy paste this one, I suppose, into this window. You can't, it's just another window here. Okay, paste. Okay. So blank sketch is loaded. Copy paste it into this window, and all it does is turns the LED on for 1000 milliseconds. That's 1 second, and then it turns it off. So it will just blink the LED on and off. Okay, so now we click the arrow here to upload. Let's see actually if it's all set up. COM port 8, COM port 14. Okay, that's my ESP. Okay, it should be one of these COM ports, but actually I'm not sure. It should be auto selected, so I suppose it's this one. Okay, yeah, upload. Let's see how it goes. Save. Okay, yeah, let's save it. So it's compiling the sketch. Uploading. Problem. Okay, what's the problem here? Okay, let's just reduce it a little bit. Arduino on COM port 8. So there's been a problem. Okay, well, let's change the COM port. Perhaps it's 14. So okay, now that the COM port is on 14, let's try it again. Okay, done uploading. Okay, excellent. So yeah, it works. This is the blank sketch, and now as you can see on the Arduino, it's just a simple blink on and off every second. So let's just to make sure, let's unplug this. So this is running the blink. Let's make sure the other one is also running the blink. Let's upload exact same source code to both of them. Let's see. Okay, and now let's see which COM port this is on. Arduino. Here we go. COM port 14, COM port 8. I suppose it auto selects the one that just connected. Let's try it. Okay. Okay, upload. Let's see if it uploads. Oh yeah, it's done uploading. Okay, so it was successful. So both of these Arduinos now have LED on for 1 second and then LED off. So both will function identical. Okay, here we go. So we don't need that. We can unplug that. Okay. So now that we have the blink sketch, we can actually remove it. And then we can plug in. Okay, let's do this one at the top. How do I have that? Let's put this one at the top. And then let's put this one at the bottom. Okay. And then so we're going to connect it. And this one, I suppose black. And then yeah, let's connect it already. LED on. And then this one, the white. And then plug it in here. Okay. So this is on like this. Let's rearrange it a little bit. Okay, yeah, the problem is that this power bank automatically turns off after after like a minute, it seems like. I think there's a protection if there is not enough current that's being taken from this power bank. It automatically shuts down, so it doesn't leak any energy out of it. Yeah, this is a cheap power bank that I bought on eBay from China years ago. I'm surprised it still works. This is a kind of interesting 12,000 milliamps, 44 watt hours, which is impossible. That's insane. Yeah, it would have to have 4 1860 650 batteries, and each one of them at 3,000 milliamps, which is, yeah, this it's a cheap knockoff. It's not going to have that. But the problem is it turns off while it's monitoring, so we might have to bring out another power bank here. But as you can see, let's see, you can have a look at these multimeters. This is the cheaper version, KWS-V20, and then this is the more expensive one, MX18. In fact, what we can do, yeah, we have these things here, so we can put that on screen. But actually, what we can do, maybe we can zoom in a little bit on, yeah, it turned off again. Okay, let me see. Let's power it on. Maybe we can zoom in a little bit to give you a better detail. Just bear with me a little bit. Let's see. So let's turn this on. Okay, here we go. Yeah, so we have a little bit of zoom here. However, I can see that the quality is a little bit something, there's like interference, so it's like shaking. I think it's because it's locked. So let me just turn this off for a moment, and then just going to go into my phone and unlock it properly, and then go into the camera app again. Okay, so let's turn it back on. Okay, here we go. Yeah, a much better picture. Yeah, sometimes this happens if the phone becomes locked and you're making videos like this. You have to come back and unlock it. I'm gonna try to figure out how to fix that. So in case you're wondering, this is OBS. That's how I'm able to mix all these cameras at the same time, use my phone and stuff like that. So and I'll make a video about that in case you're wondering and you need an explanation with some stuff. So here are the two power meters, the USB power meters, and as you can see, the one at the bottom is a lower resolution one. It only has amps. Okay, I'm gonna have to be turning this on and off. It only has amperage up until okay, let's focus a little bit, until 0.01. So it's like a really kind of like a low resolution. It's okay for higher currents, but actually for Arduino is it's a very inaccurate, you'll get a very inaccurate reading. That's what I wanted to show you guys actually. The voltage is fine. It's the resolution on the one that's the lower one is a little bit, the frequency of the update frequency is actually a little bit slower. I think it's like once a second, and then the frequency of the one at the top is a little bit faster. So you have, okay, let's focus on the one at the bottom. So you have the 5 volts going in, that's the voltage, and you have the time, however long the device has been connected, and then you have the amperage that it's consuming. It's consuming about 10 milliamps, which is a little bit more than that. It's actually not true, as you will see in comparison to the one at the top. It's actually consuming a lot more. It's double, around 22 at the moment. And then you have the time, and sorry, not the time, but milliamps. And the milliamps will be able to show you the consumption, that basically the amount of power that it has consumed in milliamps in the amount of time at the top. Okay, so time versus consumption, that's very good. And it's has memory, which means like if I were to, actually I'm not sure why these aren't moving. Let's have a look. It has it should be this time here, unless it's because I think it's because it's minutes. And this power meter, this power bank keeps on turning it off. So actually yeah, this should be moving eventually, like after a minute, but since the power bank turns off, maybe if I keep on holding or pressing the buttons and every now and then, I'll get a new power bank in a moment if this doesn't work. Okay, so we have this one, and then just can have a look at the Arduino, and yeah, that's a really good resolution. You can actually really zoom in with this. You can, let's see if I can zoom in on the power here. yeah, you can read all the pins quite well, maybe even better than if I had it in front of me. No, probably not. Okay, that's impossible. Okay, so we have, okay, this turned off again. So let's have a look at the one at the top very quickly. So this one, the MX, what is it? This one is MX. Let's move this a little bit. Oops, not this, not this. What is it? MX18. That's what it is. Okay. Yeah, let's move the cam a little bit better here. So maybe, okay. So the MX18. Let's have a look at this one. The voltage is at a much higher resolution. Okay, just restarting one more time. The amperage is 3 digits past the decimal point, so that's a really much better resolution, an extra digit more than the other one. And then you have two readings that are being calculated, the power consumption in milliamps and the power consumption in watt hours at the bottom here. Okay, let's see, we can zoom in. Wow, yeah, we can really zoom in on that. Should have just done it at the beginning. Okay, it also measures the temperature. I suppose this is okay, let's power it on one more time. I suppose this is the temperature of the USB multimeter. And then you have the resistance at the top, and then you have the watts, and then the time, and that's it. So this is really useful. Okay, what I'm gonna do, I'm gonna try to bring in another power bank or plug it in directly, because as this keeps on turning it off, because it's not the Arduinos are not consuming that much of power. So actually the power, that's why the power bank keeps on turning off. Okay, so I'm back. I've changed the power bank here, so this one actually doesn't turn off. It detects that some energy is being used, and it's working fine. So what I'm gonna do, I'm going to reset these again very quickly just to show you, and then show you actually, well, it needs to be plugged in to reset. So plug this back in. Reset this one. Actually, we're going to do it at the same time. So how to do that? Okay, let's reset this one. Okay, unplug. Let's reset this one. Okay, unplug, and then I have no idea how to turn this off. Actually, still blinking. This is a wireless charger, and USB charger, and it's both USB micro USB, and then also USB-C. So it's double input, two inputs, and then two outputs, of course. Then if you place a phone that's wireless phone, wireless charging phone, you can just place it on top. This one isn't, so I can't run. No, this one isn't. Anyways, another video probably. But yeah, let's plug these in. Let's plug this one. Let's plug in this one. Both of them start up at the same time. Okay, and they're going. So I'm gonna leave this for a bit. We're gonna zoom in on these meters a little bit, and let's power up my phone here. Okay, let's see, maybe I'll reset it this time. Sometimes what happens when you okay, and disable notifications. Okay, just because I'm keep on getting messages. So let's disable that. Enable do not disturb. Okay, here we go. So have the camera up now, and if I turn this, if I go over here, Okay, you'll be able to have a view like I'm having, which is very useful. Okay, everything works just like on the phone. So we have both of the Arduinos here. Let's zoom in on that because we have a really good quality now. Let's zoom in on the blinking LEDs. Oh yeah, that's really good. This camera, like, you'll be able to even solder. Um, you'll have a pretty good view from here. Okay, so we have both of the Arduinos blinking, running the blink sketch. Okay, and then let's have a look at these. Okay, so we have time. As you can see now, time is 1 on let's focus here. So you can see the time is changing now. The power consumption is 4.82 volts at 0.10 milliamps. But actually, as you can see, what we will notice, actually, what I'm gonna do is place these, leave these on the side for a while, for maybe, I don't know, 10 minutes or 1 hour. Let's see, until the power bank turns off. And actually, well, I can monitor the time here, and just to see the difference between milliamps that's being consumed and reported. Because, you know, if the resolution is not as high on this one, then that means that the results, the milliamps consumed in the time, is also not going to be as accurate. Okay, so we will find out if that is true. Let's have a look at this one, the better version, actually, very quickly. Let me see, we can zoom in probably on the digits. Oh yes. Okay, so we have a really nice view of what's being shown. We have volts at the top, as long as my hands aren't shaky. We have volts at the top, up to 3 digits, 3 decimal points. That's a really good resolution. And then we also have amps, and it's showing us 37 milliamps, also 3 decimal points, up to 3 decimal points on this one, which is great. We can see that so far it consumed 2 milliamps in 3 minutes and 40 seconds at the top. And there's a resistance of 131.4 ohms, and the temperature, which is the temperature of the sensor, at 32 degrees Celsius, which is nice. I'm not sure if you can change this to Fahrenheit. I believe I did see options, but I'll have a look in a minute. Okay, and then 12 milliwatt hours, 12 milliwatt hours. So that's kind of useful. Okay, so let's have a look. So this one, it's still showing that it hasn't consumed in 4 minutes. It hasn't consumed anything. No milliamps have been consumed, which is false, obviously. But yeah, that's what you get with the lower resolution. It was actually fine for higher voltages and higher resolutions. This is not going to matter, but for little things like microcontrollers and Arduinos, that's going to make a difference. Okay, so I just want to see if this moves up a little bit, and then I'll see if I'll be able to get into. I believe there's an options menu in the MX18, in the black one, and in the more accurate USB multimeter. There's like kind of like an options, and you can change some settings on this. But overall, it's a really good. I really like this one, this USB MX18. That's a really good one. I really liked it. Now, one thing that's interesting is that if we turn these off, if we turn off the power bank, or if we unplug it, they will keep the memory in them, both of them. So let's do that right now. So let's plug this one back in, and then see the time is still there, five minutes, and if the milliamps were there, they would have been kept in memory as well. So let's have a look. Okay, let's put this down. Actually, let's plug this in. Okay, much better. Sorry about that. So yeah, the memory is being kept. You can see 3 milliamps has been consumed. On this one, nothing so far. So oops, it's out of focus. So I'm curious if I do a time lapse, what difference would there be between the two of them? It's actually quite interesting. In fact, that's I might do that right now and then make a little follow-up video, or no, I'll include it in the same video. Okay, so just bear with me, and you'll be able to see the difference between them. It's actually quite interesting that it's showing 0 milliamps so far. The resolution is really going to be off with this. Okay, so let's let's turn this off. Okay. And stay with me, and I'll be back with another video, like a time lapse. I'll leave this running, and I'll see we'll be able to see the difference between the two of them. Welcome back. Okay, so it's been over an hour, and I just continued monitoring these. Actually, I'm gonna zoom in over here. And what happened was that an interesting thing happened, that there's something quite a difference between them. Well, this one, first of all, the one at the bottom is showing that, okay, let me stabilize that, it's been on for 56 minutes, and then it only consumed 8 milliamps, and the other one is showing this one is showing that it's been connected for 1 hour and 6 minutes, so that's like a big difference, and it consumed 39 milliamps. So 8 milliamps versus 39. Yeah, that's quite an interesting phenomenon. Well, discrepancy between the two. So yeah, I'm not sure what's going on here. I think maybe one of them is disconnecting because it doesn't have insufficient power, or basically another conclusion is that this the cheaper Keweisi V20 is unable to, because of the lower resolution, is unable to measure the milliamps properly. So that's something interesting. Yeah, that's happening over here. And in fact, I have another one. I have another power meter, and in fact 2 more that are USB. And what I'm gonna do, this video is just taking way too long. What I'm gonna do is I'm going to measure all 4 of them at the same time, and both of them are Keweisi. So just to make sure that everything that it's not the power bank, and it's like I'm going to power it up properly. But so far it looks to me that it looks like both of them they are on, and basically they're using the same amount of voltage, and basically the problem is that for such small resolutions, the Keweisi one, the V20, is just not enough for Arduinos and for microcontrollers. It's not going to be accurate. The reading that it gives you is not going to be a very good one. So it's better that you get yourself the other one, the MX18. Okay, so this is the winner. This is the winner, and for a few euros or dollars more, um, this is a much better one. I recommend this one. um, yeah, the difference is $2. Maybe this one is like €3 or $3 or something like that, and then this one is maybe 6 or 7 on eBay. So but take note that this is not a bad one. This is actually quite good for things like that use higher voltages and amperage, like webcams or any USB devices, phones when you're charging them, if you want to monitor how much it has been using. This one is not going to make that much of a difference. It's going to be pretty accurate with higher voltages and amperages, but as this one doesn't have enough resolution, basically overall the milliamps here is not going to be accurate. That's the only thing. And basically the amperage below 0.01 point, if you need 3 decimal points, that's not going to cut it. So but this one is yeah, I'm going to use this one from now on, for the sake of accuracy. Okay, so thanks for watching this video. If you liked some of the stuff here, if you found it useful, leave me a comment. If you have any questions about this setup and how I measured it, if there's something that I missed, I didn't cover in this video, or simply if you have other questions that are not related to this video title, but like video editing and such. Yeah, I'm able to record video wirelessly on my phone like this. It's that's going to there's going to be another video very soon. In fact, stay tuned, and if you like this stuff, subscribe, and I'll show you. I'll keep these videos coming. Yeah, I'll see if I can make a couple more of them.